Good morning, my dear students. Today we discuss about the Unit 5 Isoparametric formulation in the subject of finite element analysis. It is a very simplest subject. It is a very simplest unit as compared than other 4 units. What do you mean by isoparametric? Before going the isoparametric, we hear the brief introduction about the Unit 5 subject, 5 units. The finite element method is a powerful technique for engineering problem involving its complex and irregular geometries. Generally, we know that the finite element application actually is a very difficult to represent the curved boundaries and the straight edge element because we losing the curved area we are presenting the straight edge element. For the problem involving curved boundaries, the isoparametric element is the best method to solve. It is an example of isoparametric element. So it is a parent element, it is a mapped isoparametric element. Look at the diagram, it has a straight edge. It has some curved edge. So isoparametric element is suitable to represent the curved element. It is another form of the element, is a rectangular element, and then it has some definition. Suppose a university asking the definition of the isoparametric element, you can write the red color word. The finite element analysis is the isoparametric element. The shape function, generally shape function are used to define the geometry as well as displacement. If the shape function defines the geometry as well as displacement as same, means the element is called isoparametric element. Is a superparametric element, means the element which more number of nodes are used to define the geometry as compared the number of nodes used to define the displacement. Because this type of problem we need more concentration of geometry as compared than displacement. Suppose we can use superparametric element, means which is less number of nodes are used in different geometry as compared to the number of nodes are used to define the displacement. Because this type of problem we need the more concentration displacement. It is a diagrammatic representation. Look at the diagram, it has 8 nodes. The node is denoted as a dot. First diagram isoparametric element, the both node define geometry as well as displacement. Is a superparametric, not as compared than previous. It's entirely different for the isoparametric. It have more number of node to define the geometry. Last one's more number of node used to define the displacement. It is a subparametric. It is a formula for one-dimensional shape function, the isoparametric formulation of bar element. Displacement function x equal to n1, u1 is here the displacement about the x-axis or y-axis. It is a shape function of 4-node rectangular element. It is a diagram. It gives some natural coordinate as well as Cartesian coordinate. It is a formula 1/4 1 minus zeta into 1 minus nu. You can understand how the formula is written in this method. It is Jacobian matrix. Generally, Jacobian matrix is combined with, look at the formula, it's combined with natural as well as Cartesian coordinate. So, Jacobian matrix is derived from natural coordinate or global coordinate or Cartesian coordinate. It is connected between the isoparametric element to the normal parametric element. It is a strain displacement matrix is generally denoted as a B. When we are solving the problem, we can understand how to use the formula. This stiffness matrix, first line is denoted as a global stiffness matrix. Second line is a isoparametric quadrilateral element. What do you mean by quadrilateral element? Means nothing but the element have more than 3 nodes. if the element have 3 nodes on the line is called isoparametric element. It is the stiffness formula for the natural coordinate. The formula itself is just a modification of the Jacobian matrix. So look at the here. It is a Jacobian matrix. It is a stress-strain relationship matrix is called D matrix. It gives the two-type formula for the plane stress condition as well as plane strain condition. When we can use some thin plate, the application formula is a plane stress condition. We can use some circular or cylindrical application, means we can use plane strain condition. The E is Young's modulus, V is the Poisson ratio. It's a force vector. Force vector is generally denoted by the shape function. We have discussing about the one problem. Look at the problem. Evaluate Cartesian coordinate of the point P. We need to find out Cartesian coordinate. If the problem itself have natural coordinate as well as Cartesian coordinate of 4 point. It is a given problem. You can write what is the x1, x2, x3. Similarly, y1, y2, y3, y4. Is the formula. Before find out the coordinate, we need to find out the n1, n2, n3 value through the formula. You can substitute just natural coordinate of the formula n1, n2, n3, n4. You got the value. Again you can substitute x equal to n1 x1 plus n2 x2 plus n3 x3 plus n4 x4. You can substitute the value, you get the answer. It is a Cartesian coordinate of point P. Kindly solve the problem in your note, then only you can understand how to derive. Next is a isoparametric element, 4-noded quadrilateral element as shown in the figure. Determine the Cartesian coordinate. Similar sum we are already discussed. First you can write coordinate x1, x2, x3, x4 as well as y1, y2, y3 and y4. Is a formula n1, n2, n3. You can find the value of n1, n2, n3, n4. You can substitute, you got the Cartesian point. And next we need to find out natural coordinate. The Cartesian coordinate of the point is B is given 7, 4. It's another one type of problem. You can write what is the Cartesian coordinate of point P, x and y. Similarly, coordinate point x1, x2, x3, x4. After by using the formula, you can find out n1, n2, n3, n4. You can substitute the value of Cartesian coordinate point P, x equal to, it gives two equation. Solve the two equation, you got zeta and nu value. After zeta and nu value is the answer of the natural coordinate of particular local point of the P. I hope you will be understand how to isoparametric differ from the normal two-dimensional element. After that we discussed the problem how to find out the Cartesian coordinate of the particular point inside the element. Thank you for listening my video. Student, I hope you should be understand what we discussed here. Do you have any doubt, kindly ask me through in your Google Classroom as well as in my WhatsApp mobile number. Thank you.